Hi, I'm going to talk a little bit about elevational gradients. Elevational gradients are a great system to ask lots of questions. You can make predictions based on elevation. You might predict an increase or decrease in some pattern that you observe in nature. But there are some tips and some tricks to surveying these gradients that will make a research project more successful. So here is a sample elevation gradient. High to low. Here's low, and here's high. Okay. And say you're curious about species richness along this elevational gradient. For birds, there's a lot of research out there that focuses on bird changes along elevational gradients, especially large gradients from lowland to montane habitats. And one prediction is that there are a lot of species in lowland habitats, and that number tends to decline as you move up the side of a mountain. Other studies have found that actually you find your highest numbers of species here in the sort of the middle range, and that's because you have montane species spanning down this way and lowland species that go up to some level of elevation and then they overlap in some middle point. But regardless of what your prediction is, elevation gradients are really interesting. It does tend to occur that to most people when they first start thinking about elevation gradients, that the best way to go ahead and do a study is to walk a trail from the bottom of the mountain or the hill or whatever the gradient is up to the top, doing samples, conducting point counts, throwing vegetation plots along the way. But this is actually a confounding study design because the transect itself or the route that you take itself could be having an effect on your study. And then your samples actually are not completely independent from one another. So when you're looking at elevation gradients, it's important to have your sampling design occur in parallel bands to set elevation bands. So say I want to have samples that are in the lowland area, sort of in the mid to low elevation area, upper elevation, and then at the very top. If I'm doing that design, I'm going to have my plots or my transects, whatever the sampling unit is that I'm looking at, run parallel to that band rather than running from a lower elevation to a higher elevation. That way you're getting rid of that confounding effect of the changing elevation that will be associated with the changing of the timing of your plots or something else that might do with the route, okay? So when you're doing this kind of sampling, making sure you're going parallel in different elevation bands will ensure better observational strength, better strength of your study when you're looking at elevation gradients.